This is section 5.2, trig integrals. We're going to kind of divert our attention to some trig integrals that are a result of the logarithm integration that we learned in the previous video, part 1 of 5.2. So these are the basic trig functions. They're integrals based on now logarithms that we learned in the part 1, 5.2. So what I kind of did is I made all the ones that have a negative in their answer red, and all the positive ones the blue. And one way I remembered them, is to remember which is positive, which is negative, is that if the antiderivative answer has an O in it for cosine, ln of cosine, it's also going to have a negative. It's also true for the ln of negative cosecant and then cotangent. This has an O in it, so it's going to have a negative in front. And there was a little bonus video that shows how the integral for tangent turns out to be negative ln of cosine. So if you're interested in how you go from a trig function to a logarithm, then just go ahead and watch that bonus video. It's fairly quick and fairly straightforward. Alright, so now we have these new integration rules at our disposal. Let's go over a couple of examples. First one's going to be to find the area under the curve of secant 2x from negative pi over 6 to pi over 6. Alright, so this problem has a lot going on in it, so I'll try to go through it slowly and have it make sense to you. So I'm looking for the area, so I'm going to find an integral. And it tells me it's going from negative pi over 6 to pi over 6. It's really going to be my limits. So I'm going to find the integral from negative pi over 6 and pi over 6 of secant of 2x with respect to x dx. And notice all these kind of have the argument, whatever the variable, as u. So they're kind of set up for u subs. So we're going to let u be the inside of secant. So in this case, I'm going to let u equal 2x. And the derivative is going to be the derivative with respect to x is just going to be a 2 dx. I don't have this 2, so I'm going to factor it out in front, or divide it over, I should say. So now my integral is going to be the integral of secant of u, and the dx gets replaced with 1/2 du. And since I have limits and I have a u sub, I'm going to go ahead and change my limits. So if my lower limit, if I plug in negative pi over 6, it's going to be 2 times negative pi over 6, which just becomes negative pi over 3. So my new lower limit is going to be negative pi over 3, and my upper limit, by the same process, is going to be positive pi over 3. So negative pi over 3 and pi over 3 are my new upper and lower limits. Alright. So continuing, I can factor this 1/2 out in front. So it's going to be 1/2 the integral from negative pi over 3 to pi over 3 of secant of u du. And then the integral for secant is ln of secant plus tangent. So I'm going to need a little bit more space, so I'm going to continue this over here. So my answer is going to be 1/2 ln of, we said, secant u plus tangent u, and it's all being evaluated from negative pi over 3 to pi over 3. Alright, so now what I have to do is evaluate pi over 3 into secant and into to tangent. Well, let's see here. Secant is the same thing as the reciprocal of cosine. So what I can do is just take the value of cosine at pi over 3 and then reciprocate it. So cosine of pi over 3, that's going to be 1/2. So when I get to plugging in cosine of pi over 3, I get 1/2. So that's going to be reciprocating. That's going to be equal to 2 for secant. And then next thing I need to know is the tangent of pi over 3. And you can just look this up on the unit circle little cheat sheet or diagram. This is just going to be square root of 3. I've done this long enough that I kind of have this memorized just because it comes up every so often and I remember that it's the square root of 3. Or if you don't memorize it, you can just look it up. Tangent of pi over 3 is square root of 3. Alright. So when I go to evaluate this, it's going to be 1/2 ln. When I plug in secant of pi over 3, it's a reciprocal of 1/2, so it's going to be 2 plus, and then tangent is square root of 3. Close that off, and then I'm going to now subtract the lower limit. Secant of negative pi over 3 is still going to be 2, but tangent of negative pi over 3 is going to be negative square root of 3. And the reason for that is, I'll kind of draw a little, let me close this off to finish my expression here, but the reason it's negative square root of 3 is because on the unit circle, let's say this is a unit circle, negative pi over 3 is going to be in this quadrant. So this is, let's say this is what negative pi over 3 looks like. In this quadrant, cosine is still positive, and since secant and cosine are just reciprocals, it's still going to remain positive. But in this quadrant, since tangent is cosine divided by sine, one's positive, one's negative, so they're going to divide each other, and there's going to be a negative. So in the fourth quadrant, cosine and sine are different signs. So that's why this is negative. Alright. So now one last thing about this answer is that sometimes in the back of the book they'll simplify the answer based on logarithm properties, because you're subtracting this logarithm from this logarithm, and so usually what happens is they take two logarithms and then condense them into just one as a fraction. So since you're subtracting these two, they might go ahead and write their final answer as 1/2 ln absolute value of 2 plus square root of 3 divided by 2 minus square root of 3. So that brings us up to our little talking point, and that's going to be, how much do you need to simplify? Well, my answer to that is as much as you need to. If it's multiple choice, you'll probably have to match the answer, multiple choice obviously, and if it's not listed as this, if it's not written with two individual logarithms, you'll have to know the logarithm properties in order to get it to match into this. In the back of the book, I mean, they might simplify this as this, so that's another example of how much you need to simplify as far as you need to. In some cases, if you're working through a problem, it might make sense to simplify things if the next steps are going to be somewhat simpler. And you kind of just know when to simplify stuff just through experience and just through practice. And I guess the last thing is, if this is a free response question and you stop right here, you would earn the same amount of points as if you went to here. But oftentimes people don't remember the properties correctly, and they simplify incorrectly and they mess up or whatever, and they would lose points because, well, basically they don't remember some of the algebra properties. So my biggest, I guess, suggestion is that if it's free response, if it's open-ended, just go as far as you can. If it's multiple choice, and sometimes you really have no other option but to match it, so it's a good idea that you commit these to memory, you memorize them if you haven't done so already, so you're able to work with them. But through practice, hopefully you'll get to, you know, be comfortable with these, and simplifying won't be too big of an issue. Alright, last example here for this video. If it says to find a particular solution passing through a given point. So to give us what the first derivative is, we want to find a particular solution, so we want to go back to the function. So if I integrate my tangent 1 over x all over x squared dx. That's going to end up being what my function is equal to. So notice my tangent rule is kind of set up for a u sub. I want to let u equal the inside part, and it may not be obvious as to how this is going to match up, but 1 over x, if you write this as x to the negative 1, the derivative of that, it's going to be by the power rule, negative 1, x to the negative 2 dx. And you should recognize this as 1 over negative 1 over x squared dx, which is what I have. I have x squared in the denominator and a dx next to it, which is what I have right over here. I don't have this negative, so I have to divide this over. So now it matches with what I have. And so my integral is going to be the integral of a tangent of u with negative du. So again, this x squared and dx in the denominator for x squared is right over here, and this dx is next to it. That gets replaced with negative du. And I was able to do this because the derivative of x to the negative 1 is negative 1 x to the negative 2. Go ahead and factor out this constant, so negative integral of tangent of u du. Going to my antiderivative, the antiderivative of tangent is negative ln of cosine. So my answer is going to be negative ln of cosine of u plus c. In this parenthesis, I don't like the way it looks. I'm going to change it. Two negatives cancel out, so I have ln, absolute value, cosine. I don't have any limits, so I go back to what I selected for u. So it's going to be 1 over x plus c. And this is my general antiderivative. So at this point, I want to apply my initial condition. I want to apply the point I was given. So this is my x coordinate, this is my y coordinate. So I have 1 over pi, and then the number 4, this is x, this is y. So it's going to be 4 equal to ln, absolute value, cosine of 1 over, and the x value is 1 over pi, plus c. And this is going to be kind of weird. I have 1 divided by 1 over pi, which just reciprocates to cosine of pi, plus c. So simplifying this more, I have 4 ln. Cosine of pi is going to be at the very far left of the unit circle, so it's going to be negative 1 plus c. So 4 ln of 1 plus c, absolute value of 1 of negative 1 is 1. And so ln of 1, luckily for us, doesn't get too funky or too weird. It's going to be 0. So it's going to be 4 is equal to c. So your particular solution is going to be ln, absolute value, cosine of 1 over x plus 4. And that is your particular solution. And we are done with this video.